And we're live. Sweet. What's up, y'all? Okay. Let's see. Where's Discord? And cool beans. Let's actually take a look at this. Oh, there's someone posted this in my channel actually. Snap plans to lay off 20% of employees. All right. Snapchat's lay off more than its 6,400 employees. Planning for the past several weeks. The team working on ways for developers to build. So it's like an SDK inside Snapchat. To build mini apps and games inside Snapchat. Okay, so there's like some external SDK project, which kind of makes sense. Not central to the core operating flow of Snapchat. Although it's a very interesting product. I would definitely like to have seen this. Zenly, a social mapping app bought in 2017 and run separate. We'll also have see deep cuts. Yeah, this is like probably they probably were paid for this one. Snap hardware division, AR spectacle glasses. Basically, it looks like they're cutting a lot of things for what's it called? The extraneous stuff. Snap does not comment on layoffs. 8% of value. Decimal second quarter earnings. Aggressively during pandemic. And then buying for more than 500 million. Okay, that's a lot. Navigate Apple's crackdown on ad tracking. Snap continues to grow, which is more on Twitter, but only has managed to turn a profit once since going public in 2017. Okay. So I think someone in my chat pointed out that I did a valuation on Snapchat, and I pointed out a lot of red flags. The two biggest ones are the operating cash flow, which turns out to be a pretty good predictor of who is laying off and who is not. So if you applied that heuristic to any of these tech companies, so whether that's Robinhood, Snapchat, DoorDash, well, I don't know if DoorDash, but in general, if you applied it to a lot of tech companies, you would begin to figure out who was going to lay people off and who wasn't. Like, probably at least 6 to 9 months ago. I think I did that. Someone said I did that stream in mid-January. And so, yeah, turns out if you just look at the fundamentals, you can actually figure out what companies are going to be in trouble when times are bad, which is ironically coincidentally happening right now. So that's the first point, operating cash flow, which one's thin. Second one is how much of their books are bullshit. In this case, in general, one of the rules of thumb is that goodwill is almost always bullshit, because in tech companies, when tech makes an acquisition and they're overpaying for something, no tech company lasts longer than the length of depreciation. So when you're doing amortization and depreciation for GAAP accounting, I think you depreciate it over n number of years. I think GAAP does this for 27 and a half years for acquisitions, but for software you can depreciate it along 3 to 5 years, I think. But for acquisitions, no software company lasts, well, very, very few actually. Very few software companies last 27 and a half years. So the balance on goodwill on your books for a lot of these companies that overpay, it tends to be pretty bullshit. Now, I would have said that if you're overpaying for something, then chances are you want to pay with a more equally overvalued asset. So let's say, for instance, Snapchat. Let's go back to this deal, right? If they bought Wave Optics for 500 million, but then they use, let's say, their overpriced stock value. Let's actually look at Snapchat stock. Just as a toy example, right? Let's say that they bought the company with $500 million worth of Snapchat stock at 75, like when Snapchat was trading at $75, $80. I think that would have been a magnificent purchase for Snapchat, actually. One, clearly because $80 probably overvalues the company. So let's say at $80, assuming no dilution, what's the market cap? 16.5 billion. Okay, so that would give it about $100 billion market cap or something like that. So let's say you basically gave up shares in a $100 billion company that's really worth, like, let's say $15 billion, assuming that this is the fair market value. So you traded something 8 times overvalued for something that maybe 2 times overvalued. That's a magnificent trade, in my opinion. So to put this into perspective, let's say I offered you like an iPhone, right? iPhone's $1,000. So 8 times that's like $8,000. So let's say it'd be like saying, hey, yeah, I'm gonna exchange my iPhone for 1 month of rent. When rent goes for like $1,000 or $2,000, I think that's a pretty amazing deal actually if you're in the Bay Area. Um, like or let's no no let's say 4 months of rent. Would you trade your iPhone for 4 months of rent? Yeah, yeah. Assuming you're paying $2,000 worth of rent for 4 months, yeah, yeah. I think anyone would take that deal. So it's the equivalent right here. If Snapchat had actually exchanged their stocks for the companies that they were acquiring, I think it would have been magnificent. So let's see who's in the chat right now, and I'll answer some questions. Okay. Yo, what's up? Let's go, Edward. Back at it with the sessions. Yeah. I think one of the beauties of me being able to do streaming and coaching like this is that pretty much I get to do it whenever I want. I think it's a very nice. Um, it's very nice because I can take a break whenever I want. I can stream whenever I want. I can make the sessions private whenever I want. But I generally tend to favor streaming. One, because it holds me publicly accountable for my results, and two, you guys get to learn something as well. And not to mention, it's easy for me to like talk shit, right? And I admit I do talk a lot of shit, but when it comes right down to it, I need to have results to prove, and this is the easiest way for me to show that I can get results. You know, instead of me just like hiding behind testimonials and whatever, if I just stand out here and do it, and you guys see it, it's the easiest way to see if I know what I'm talking about or not. You know, and there's always going to be people who say, oh, yeah, that's what Edward said is true today, but not true tomorrow or whatever. And it's like, okay, I'll just keep showing up on the stream and just doing it again and again. It's like the people who think Warren Buffett's lost it, like because he underperformed the S&P for the past, I don't know, 5-7 years or whatever. Let's see. Let's see. The fact that he makes his records public, gets people around once a year, and just kind of answers questions and holds himself publicly accountable, I think is a really great mechanism for him to really just how to say, maybe the learning side, the teaching side of his personality and stuff. It's a really good incentive, I think. So I don't really trust. I would say I wouldn't say I don't really trust. I would say I diminish the amount of trust that I give people who don't really stand by their statements in public, and who aren't consistent as they are in public versus private. The background looks different. Are you at NYC right now? Nah, I'm at my parents' place. So short version. I moved out of my old place because I'll be in New York City in 2 months, so I kind of figured it'd be a good time to give up the rent. Before I was like I was in like SF for a week, and holy shit, I hated it actually. Like SF is pretty much dead Monday, Tuesday, Wednesday of the week. Thursday, Friday, Saturday, Sunday, you're pretty much out there, but you're only there to socialize and drink. So I am utterly convinced that the only people who live in SF are the people who work. That's it. You don't really live in SF for fun. You live in SF to work and then socialize with other work friends on the weekends. That's it. So I'm like, wait, why the heck would anyone ever want to live in SF? So I gave them after like 3 days, and then I just moved out just because. Okay, well, I didn't want to overlap. I thought maybe at the time I was gonna maybe live in SF for a little bit longer, but given how much I disliked it, I was like, screw this. So I think I was over eager on giving up the rent. So I'm just kind of bumming it at my parents' place right now. So the upside is that it's rent free. So I'm gonna try to find a new place in like January or so. But yeah, in November and December I'll be in New York. Hopefully my laptop will be able to stream. I hope. Like it's a very underpowered laptop. I don't know if it's built for streaming, but we'll see. We'll give it a shot. And worst comes to worst, I'll just like buy a MacBook over there or something like that. All right. Anyway, that's my thoughts on tech. Let's see what Hacker News has to say. Savings going up. Dude, at this point, me saving money on rent is not like gonna make a huge difference. I'm gonna tell you that. I'm not gonna reveal like. Yeah, I'm gonna say like saving $2,000 of rent or whatever is not making a dent. Really, I just like having a place to myself where I can wake up at like whatever time and go to sleep at whatever time. One of the reasons why I like having my own place, especially in the beginning, was basically, yeah, just so I can go to bed like 2-3 a.m. and make noise whenever I want without pissing people off. I imagine my roommates, if I had any, would have been extremely annoyed. Anyway, let's bring on my client and let's see what's up. PM, 8 p.m. Hello? Hey, hello?
Hello?
Hey, what's up?
Hey, how's it going, man?
Hey, doing good. How about yourself?
Good, good.
Oh, okay, wait, hold up. I just realized I'm not getting your audio. Give me a sec. Audio. Input capture. Wait, where's the desktop capture? Okay, audio output, desktop audio. Okay. Oh, can you say something?
Hello?
Oh, wait, hold up. It's not.
Okay.
Give me a sec. Okay. Try again.
Hello?
Yep, there we go. Cool, cool, cool. We
Okay.
got it. We got it. All right, cool. Yeah. So, say hello to the stream.
Hello.
Hello.
Awesome.
All right, cool. So let's do a little bit of background stuff. I know you quickly told me about like your situation and stuff. But for just a quick recap and for me to take notes, just kind of go over your situation.
Okay, so I had a phone screen with Facebook in the beginning of January. I got COVID. I bombed the interview. And after realizing I had COVID, I kind of realized why, because of the brain fog and not thinking clearly. But after that, I decided to read the guide again, go through Grokking chapter, Grokking the system design, Grokking interview patterns. So I went over that, and then I also kept a diary and also recorded the problem solving and try to iterate on that. I had my phone screen with Amazon last month or two. That's passed. So now I have to set up I already have on-site with Amazon, and I have to set up the Google one.
Okay. And you are basically aiming to try and knock this all out by end of September, right?
Correct. Yeah. So the 30th of September, that's my Amazon one, and I'm gonna do the Google one a week or two after that.
Okay.
Depending. Yeah.
I'd recommend like probably 2 weeks, because you have to wait for Amazon to get back and then incorporate the feedback, right?
Okay. Sounds good. Sounds good.
So let's say 10-15 or so for Google.
Okay, that works.
All right, cool. And Amazon, you said you're going for an L4 level, and then Google for an L5, right?
Yeah, correct.
Okay, cool. So let me write that down here. Let me share with you the prep doc that I'm making.
Cool.
Okay, cool. And since you've been able to pass through the phone screens for both Amazon and Google, and it seems like you're pretty much good on that. And I think the most of what we're going to be spending our time on will be just the system design. So,
Okay.
but first, I kind of want to do like a spot check just to make sure that this is correct. That way, going forward, we can just focus solely on system design. So, like I said, I think we're going to split this session up into 2 parts. The first one will be will just be, hey, let's make sure that everything's good for the leak code round. And the second one will be, hey, let's make sure that we'll go forward and do the system design stuff.
Okay.
Yeah.
Perfect.
And just for like bookkeeping stuff, where do you feel like you're weakest in both the leak code stuff and the system design?
Like for example, for the leak code, I would say problems that like for example, you study graphs and trees, right? Like if they throw you something like a minimum spanning tree problem, since I hadn't really reviewed like the unifying algorithm, stuff like that, then that would kind of throw me off because this is what happened at a Google tech screen before. So yeah.
Wait, they actually gave you a minimum spanning tree problem at Google?
Yeah, they gave me the this problem was it's like the villages and wells problem. Like you can connect to a village. You have to give water to all the villages. You can build your own well at a cost, or connect to another neighboring city at a village at a cost. So.
Oh, okay. So you need to be able to deliver water to villages or dig your own well at cost.
Correct.
Ah.
Yeah, and this is like a simple minimum spanning tree problem.
Oh. I'm gonna tell you straight up, I don't remember my minimum spanning trees at all, so I'm very surprised Google gave you this one.
Yeah, I flipped on LeetCode and it was a hard problem.
Jesus Christ. I would.
Yeah.
I was like, if you gave me that problem, I probably would not be able to get it.
Yeah.
I'll tell you that straight up. So I'm like, what the fuck? But okay.
Yeah.
Okay. So the really weird complex problem throw you off. Okay.
Mm-hmm. Yeah, and also arrays, because arrays are always hard to work with. They have different ways of solving them. It's not like graphs or trees, right?
Yep.
Yeah.
Okay, and then the system design, would you feel like you have any particular thing that you suck at, or do you think it's just all suck?
So from last year, prepping for this, what really threw me off was like coming up with the numbers. Like for example, the traffic estimates, the memory estimates, storage, etc.
Mm-hmm. Okay, so it's basically being able to just start it off. Got it.
Correct. Yeah.
Okay. Cool. With that, I think that's enough bookkeeping for me. Let's get started with practice problems and see what's up.
Cool.
Okay, so I linked you the problem sheet. Let me go ahead and bust up the timer.
Okay, 1 second. Let me open this in Chrome. Also, one thing, so you know how like when you're trying to draw like the stack trace and all that, is it acceptable to do this like on paper in the interview, or is it strictly on like a Google sheet for these?
So here's the thing, stack trace, do it when you want to debug your code, but in general, you should be able to have like a flow where in general you kind of understand how each piece goes together. The stack trace is really just a exercise that you should be able to do at any point. But you shouldn't have to do it, if that makes sense.
Okay. Yeah.
So it's like, oh shit, I can't figure out what my bug is. Let me go step by step. You know, that's where a stack trace comes in. All right. So let me go ahead and pull out a problem. Actually, I have, oh yeah, this is a classic one, and let me know if you know how to do this one already, but... Okay, and then here we go. Alright, so, serialize and deserialize a general n-ary tree.
Okay, yeah, so yeah, I did this about a month ago. The idea is to keep some sort of list. Like for example, you have for example, let me write this down. So you have A, and then you have the children, right?
I want you to solve this holistically, as if you've never seen it before. I want you to solve it logically, as if like, you know, a real person gave it to you.
Okay, sure. Okay, sounds good. Okay, so serialize, deserialize an n-ary tree. Okay, the serialized portion, it looks like to define the data structures, let's say it's a node, data, and children, right?
Okay.
Children is going to be a list. and data is like just like a string, right?
Sure.
So based on this, I want to take a depth first approach. For example, looking at the example, I'm going to go from A's first children B, B's first children E, and then from there, I want to output the data as it comes. I'll put it in some sort of string or list. This is to serialize into a string, correct? Sure. That's what we're doing, right? Serialize from a data structure to a string.
Okay. And
then the deserialize is going from a string to the tree node structure, correct?
Sure. Yeah.
Okay. Okay. Cool. So idea is to traverse the structure, and so you want to traverse the structure, and you want to traverse the structure in a depth first manner, and save the output to a string. Also, you need to keep some sort of placeholder to indicate that you are done with the node, right?
Okay.
So, for example, I'm just writing this out. You go down to let's say I'm thinking maybe we can do commas. We can do A. You go down to B. Okay. You go down to E. There's nothing in E. There's no children, so mark it with like a pound sign.
Okay.
B still has children, so process those. F, and then you go to F children. K, K has no children, so we'll mark it with the pound sign. Okay. When you're done with B's children, mark it with the pound as well. When you're done processing a node. So then we go again, and then we're gonna process the rest of A's children. That's gonna be C. C has no children, so draw out the pound sign.
Okay.
Then we do the rest for D. Do you want me to continue with this, or?
I get the idea. It's very interesting. I've never seen the problem solved like this before, but okay.
Okay. So based on that, okay. So if I do it this way, given the node structure, now we want to serialize, right? Or we want to deserialize. This is
serialization because you have the string right now, right?
Mm-hmm.
So you want to be able to. So I get the idea of what you're trying to do, but I'm curious how you're going to deserialize this.
Okay. So to deserialize, let's see, deserialize. Let me see. So I have. Okay, so these can represent the end or the no children. We can split on commas. For example, split on commas to process the string, and you split up. Oh, okay, 1 second. Split on commas, then you process a string using split. So for example, that would give me A, B, E in a list. So essentially, the big idea here is I want to process this as a queue. So for example, I'm going to start off this deserialization. Let me just draw some sort of example here. A, and then you can you want to keep popping off So what I'm thinking here is doing some sort of recursive approach. So for example, I have A. and then you want to append children. For that, for example, if you have if you have an item, create the node.
Okay.
If you have, if you have a %, that means do not add to the children list.
Okay.
So let me walk this through. Let me walk through this. So A. Let me see. Let me bring down this string here. So let's say this is my. Let's process this as a queue. This is where I'm at in the queue. Okay, so let's do this. Okay, so we can say while queue item equals queue.pop.
Okay.
While item equals queue.pop, create the node. So it's going to be node item. Okay, so here, how would I now the goal is to add to the children, right? So what I can say is while okay, one second. Okay, so I have the queue, I pop off the item, I create the node, add to children of A, and let me see. So I'm thinking here, okay, so I want to pass around this queue so it can create the items. So I'm thinking of a problem I've done before where you serialize and deserialize a regular binary tree, right? So I have my queue, I pop off the item, then I create the node, then you add to children of the current item. So let me see. Okay. This case later. Okay. Yeah, I'm trying to do the design, but I'm kind of getting mixed up here, doing some code as well. Queue return. Okay, so while queue, pop off the item, create the node, recursively call function. So here I would say something like serialize with the queue, right? Okay, so I created the node, okay. Node.children.append. Give it queue. Oh, hold on. So node.children.append, you want to okay, so here, okay, children.append. So for that, it's going to be a type of node, right? So just call it deserialize. Return a node at the end. So now I'm thinking of how to handle the pound signs.
Okay.
So if not Q, you return none. While Q, okay, let me just run this through an example here. So let's see this. So let's say, okay, here, node is A, right? And then it recursively calls, it's going to recursively call the children of, so here's my stack trace, and children, that's gonna have the rest of the queue, right?
Mm-hmm.
So then we're back into the deserialized function here. Q is not none. There's still a Q. So pop off, it's going to give you B. Pop off, create the node B. B. And then you're going down to B's children again. B's children. You're back into the deserialized function. Q is not none, so you continue to process a Q. That's going to be E.
Okay.
No, that's not E. Children. Okay. So you're here. Oh, I forgot to update this as I was going here. So you're at E now. You created the node, and then you want to recursively call to add to its children. But you see that you're at the end. Going back to our example here, in the problem statement,
Okay.
E has no children. So now thinking here. Okay, so now I'm stepping into the function item. You created E right here. So I created E here. The next item is not valid. So that means there's no more items to process for this. This node is not going to have any more children because you reached the end. So I have to handle this case here. I can say, so I have the queue structure.
Okay.
I can look at the first item. So I can say if the queue exists and it is not a pound sign,
Sure.
do not bother with node append children.
Okay, you're right.
Okay.
Yeah, you mentioned that earlier. Yeah.
Mm-hmm. Okay. Let's say if Q and Q0 is not equal the pound sign, you're gonna add. Okay. Okay. Cool. So I'm here. Okay. So I'm still at E, right? Because I did not go into its children. So then, so now I'm thinking, if you're going around to the Q, you're checking well Q again.
Okay.
You popped off E. Now you're here at this ampersand, not ampersand. Sorry. You're at this pound sign. When you get something like that, you're done processing this specific node.
Okay.
So let's do this all as well. While Q and Q0 does not equal pound sign.
Okay. So
And
while
then
Q
you
and the Q is not at the end. Okay. All right.
okay, so you're done with the Q. So pop off if Q and Q 0 equals. You want to pop off that value.
Okay.
This indicates that we are done with this node. Okay, so going back to this example, I popped off the pound sign. We're at F now. Okay, so I returned node. 1 second. Okay. So now I'm getting mixed up here. You see how I created the item here, q.pop, and I'm also returning the node here. I have to figure out how to fix that.
Yep. I would even argue that your code is. It's very weird because you have a lot of things going on. One, you have a queue, and two, you're recursively going into the queue. It's not very obvious to me if this is even going to work, but okay.
Okay.
Yeah, it's weird. Okay. All right. I see what you're trying to do, and I get the idea, but it's very fucking weird. So. Okay. So you're iterating through the queue, and if the queue up until the queue doesn't equal, a pound sign, right? And then you're popping through the queue, and then you create the node. Okay, and then you create your node, fine, with the queue item, and then once the queue item gets popped, then you have recursively call.
You're basically so my idea here was to do like a depth first on the queue items and keep adding to the children. Right. So for example,
okay, so you create the node item, add to the and you add this node. Okay, fine. So you're just gonna keep adding to the children, and if you still have items in the queue, and then the queue doesn't equal to the end. Doesn't equal like a breakpoint. Okay, then you're gonna append whatever is in. Okay, I see. You're gonna append to the children just as a Okay, so then this. So okay, A, B. I get this. You deserialize, and then you come out of it because then you would have processed E. You come out, and then you start back at the loop again. You go to F. Node, and then K is a K. Okay, that's fine. I understand what you're trying to do here. And then you just keep doing that over and over again.
Correct.
Okay, I see what you did here. I'm just thinking if this work. Okay, that's fine. And then if Q and Q equals to pound sign Q pop. So that's okay. So at the end, the thing is that why is this D here? Shouldn't D have a pound sign? Oh, D doesn't have a pound sign at the end. Okay. Why doesn't D have a pound sign at the end when you're done serializing?
Oh yeah. I think that because when I was explaining the idea, I didn't write down the whole value of the tree there.
I see. So then my question is, well, but when you're in theory when you're done with this. Oh, and the Q doesn't equal pound sign. So then you have a pound. Then at the end, then in theory you should have a pound sign at the end of the queue. Oh, you should always have a pound sign at the end of the queue. And then
correct.
The queue pop. So which means you're done with the pound. Which means you're done with the pound sign.
Correct. Yeah. So that would basically indicate that that's the end of the children of the node.
Okay. And then you return node. So you're saying node is this item that you created here?
Correct. Yeah. Yeah. Perhaps I probably put it in the wrong area there because that's what's like preventing me from going forward. It just doesn't make sense to me to continue. I would just get more confused down the line.
Why are you let's narrow that down. Why are you getting confused?
So I'm getting confused because here in this line here, where my cursor is, you're basically done processing all the children, right? You're at the end. You get out of the queue. You get out of the while loop. And then there's another check there where it pops the last pound sign. But there's really no, I don't think there's really a variable node, right?
There's no variable node. What do you? I don't understand.
What sorry. So here, right? If I define it here, right?
Sure.
You created the node.
Sure. Why not?
Unless I return that, but would that work though? Let me see. How do I return that node? Going back to this example here, A, B, E. This never got processed since it was a pound sign. Node is E still.
Okay.
Okay, yeah, that looks good. So this is empty, right? Because it's a pound sign. And we continued the while loop. We never added the children to E. So now this queue is telling me in this line here, break out of this loop. Node is still going to be equal to E. You break out of this.
You would never enter the queue. You would never enter that because you have this line, right?
Correct. Yeah. So yeah. So yeah. I would create the E node here. I would never enter this line, and then when I go to the while loop line here, while
right.
Q and Q, so I would never enter that line. So then here, this second check here at the very bottom, it's gonna say, okay, you have a pound, you have a ampersand, you have a pound sign, and you still have remaining elements to process.
Yes.
So let's pop off that value.
And I see. Actually, you might actually have a bug then.
Okay.
Because what you just described to me was, okay, let's suppose that in the worst case scenario, you have IGHJ, right? So you would have I pound, G pound, H pound, and then J pound. So then you would I pound. So then let's say I, and then pound would pop that, and then you would go. Then you would go back up to the D, and then you would go look at the next item in the queue. Yeah, then you would look at the next item in the queue, and then you would pop out. Yeah. Actually, that's right. So let me show you exactly where I think the bug is.
Okay.
And this is something you should have caught yourself. So let's say I'm done with processing I. I would have I pound, right? Pound would actually eject me out of all this, right? And it would return me back node I, right?
Correct.
So then now I'm looking at I would be attached. My node would be D, and I'd look at the next element in the queue, which would be G. So then now you have G here. Isn't that right?
Yeah, correct.
Okay, I see. So yeah. So you're stuck basically.
Yeah, correct.
Okay, I understand. So does that mean you want to throw in the towel, or you want to try saving this problem?
What? We're at 34 minutes.
We're at 25. I'm gonna give you another 5. See if you can save it.
Okay, let's try that. Okay, so. Okay, so here, what's this? Okay, so I'm at E, right? Okay, so going node is equal to E, right? Node equals to E. Q. The next item, it's a ampersand. It's a pound sign. So you exit out of this while loop, and then you look at Q. You see that there's still items in there, and the item left is a pound sign. So pop it off. It does not advance Q. That's just going to return E. Let me see. This is going to return E back up to B, correct? To its children.
Okay.
So then we're back at B now, right? Second. We're back. Okay, we're back at B. Let me look at the structure. B still has F and K left. So okay, so we create F. So this is another children of B. So it's going to create F, right? It's going to create F, and that gets called recursively. The Q now points to K. Okay, you look at the children here, right? Because you recursively call. You add K. You add K. You popped it off. The next value is a pound sign. So break out of this while loop.
Okay.
And then you go back, and then you pop it off in this line here. Pop it off. Okay. So then node K gets returned to node K gets back returned as a children of F.
Okay.
We're back here now because here we just added the K node, right?
Okay.
So then F node is equal to F here. It breaks out of this because it's equal to the pound sign.
Okay.
So it breaks out of this loop. It pops it off at this line here. So then this gets added to a children of B. Let me look at the structure above. Yep. So F is added as a children of B. So let me see. What is my Q looking like now? Okay, we're pointing at C now. Okay. Okay. So F. Where's F? Okay. That was added as a children of B. Let's see. So C. So, okay, yeah, this is where I kind of got confused here.
Okay.
K got returned to F as a children, and then F gets returned as a children to B. Okay, so then let me see. Okay, so this basically tells us that we're done processing the tree, the subtree that starts at B, right? Because we're now looking at this pound sign. We pop that off our Q. Return. Let me see. Return B. We're done with B, so return that as a children of A, right?
Okay.
Okay, so our Q is now pointing at C. I got to move here now. So create the node. This is another children of A. This gets added as C. Going back to the image above, there's nothing below it. So it doesn't go into the loop here. It doesn't go into this second recursive call here where it calls the serialized queue. Because you popped off C, and then you're looking at this pound sign. So then return C as a children of A.
Okay. I'm going to. You're at 31 minutes, by the way.
Okay. Yeah.
Are you gonna throw in the towel, or you think you?
Yeah, that's fine.
Okay. Let's stop it there, because okay. Let's talk about what you did right, what you did wrong. I want you.
Okay.
Yeah. Tell me about that.
What threw me off here was the recursive call and passing it in to, for example, node.children, and then passing it in a recursive function in there.
Mm-hmm.
That threw me off there because that threw in another edge case that we had to account for. That was when you look at the pound sign, and what threw me off was looking at that pound sign and handling that extra edge case that we have to take care of.
Mm.
Yeah.
I would say, okay, well, remember what I said, and I think I mentioned this before. What we're really trying to do is improve our problem-solving approach, right? So the question is, why are you in that situation? Why did you feel like you ended up in the situation where, I got confused? Let's ask ourselves that first.
I don't think the design wasn't solid enough for me to actually start the code. So what I did was I started writing some pseudocode, and then I actually wrote some actual code.
Mm-hmm.
And then I just based it off that. So the design was not solid to begin with.
Mm-hmm. Yep. So my question to you now is, knowing that, what would you have done differently? If I could send you back in time 20 minutes ago to when that happened, what would you have done?
Come up with a better stack tracing and come up with a better design. Do not code until the design is done.
You just said you screwed up the design, so of course you come up with a better design, but my question is, what is the actionable action? Like, literally, if you could be a ghost, go back in time, like fucking, what's it called, Nightmare? Was it the Scrooge McDuck? The Ghost of Christmas Past story, right? Yeah. Where he sees like all the past, present, and future, whatever. If you could literally go back in time and hand yourself a note telling yourself what to do, what would that be? It has to be actionable. It has to be something that some idiot can follow orders on.
Create a design that's solid before I'm actually write code.
Okay, a little bit more solid than that. That's the general principle that we're trying to do. You've just repeated yourself, essentially.
Mm-hmm.
But what I'm saying, like, one action that no one can screw up. Because if I like receive that note, I'm like, oh, my design is fine, and I'll just keep going ahead. What's an action that no one? Give me a declarative action that no one could screw up.
Test the code.
That's pretty good. I would say that's all right.
Yeah. So testing the design with the actual example.
Mm-hmm.
Make sure where it goes, and basically step by step. You want to trace your program. That's what I would do to not think in my head with this edge case here. Because I think that's one of the things that also threw me off, this edge case here.
Yeah, that's pretty close to what I would say. But let me go ahead and paste my notes here, and I'll give you the name, and it'll make more sense. So all right, let's go through this step by step, right? So let's start with, okay, I have no problem with you declaring the idea, and given that you had basically seen the problem, fine. I forgave that a little bit, but I would have expected you to be a lot more logical and clear about it. So I think it's interesting that you decided to use the pound sign to implement down with children, but what I didn't like was there's an implicit assumption that every single time you were going to the next string, that you were going into the children. That is, the thing about things that are implicit is that if it's not obvious, you're going to miss it. And that's exactly what happened here, is that implicit in your idea was going into children. That was the first red flag, I thought. I also, like, when you said, I'm going to use the split API, I honestly don't care what standard API you're going to use. Don't focus on the code or the actual implementation. Focus on the idea. If your idea is solid, the implementation will come naturally. But you were kind of losing me with a little bit of the logic. But the first red flag, and I think the one that killed you here was, you basically walked in the code without being clear on your idea. I literally wrote red flag at 7 minutes, and and you pretty much acknowledged, hey, that was what killed you.
Yeah. Okay.
So, it's like, did you go step by step and make sure it worked? The rest of this is like, okay, you're kind of just stuck, and then from there on, because you didn't have a good idea what you're doing, you were kind of you were floundering, patching, and praying. And the rest of it is just kind of like the fallout from that. Literally just this one mistake of like, I wasn't clear on my idea. So if I had to rewind this and I was in your position, I'd be like, okay, well, and let's say I was stuck with this, right? I never would have actually done this. I would have just done the parenthesis going to say, hey, I'm going into the node, I'm coming back out. To design which action, right? That I was doing. Make that action explicit, because what I would do is I would just say iterate as a queue, and then every single string in the queue is dictating an action.
Correct.
Okay. But then in this case, be like, okay, each time I'm looking at a node, each time I'm looking at the queue, I am going to be looking at an action, right? So in other words, let me edit this. So that means that while the queue is not empty, that means that I have at least one item in the queue, right? And queue is not popped, right? I'll pop the queue item, I'll get the node, right? And that means that everything from, let's say, here, let me copy the queue just so for clarity's sake, and then let me make this red. So what I would do here is just say, hey, everything from here B till, and let's say that this is x, I don't care, all the way until I hit the end. These are all going to be one children, but then here I'm gonna have like C. I can have like let's say Y. Up until another pound, and then up until that, and then I get a pound back, right? So in other words, this is basically what my algorithm is going to look like. So I know at the very least, A must be the first item, and then I'm just going to keep iterating through all this shit until I hit another pound. So this if would just become a while, actually. That's how you would fix the problem.
Okay.
So you notice here, all I did was take your idea, just declare, okay, implicit is that every single time I hit a node, I'm going into the node, right? And within that, if I hit a pound, then I'm going to come back out of it.
Right.
So that would literally just doing that would have fixed your code. Although your coding would have been pretty sloppy, but and that's a whole different issue. But I'm telling you right now, hey, if I just understood the high level idea, this would have saved my ass, and I would have saved the interview.
Right.
So you see here, all I did here was just say, okay, I acknowledge that I'm implicitly going into nodes whenever I see nodes next to each other, or when I see letters next to each other. That's all, and that's why I would never do something implicit like that, because it fucking kills me.
Right.
So, in fact, by that logic, then this becomes actually kind of, if it's well formed, then you should never have this. But, also like doing some pre-processing like this would never be a good idea either. But you get my point. That I would never try to recurse with a queue ever. I've burned myself many times doing it. I would do everything in my power to avoid that.
Okay.
So instead, I would have just done A, and then I'm going into a tree, then do B, comma and then I'll close parenthesis to indicate I'm going out.
Okay.
So your structure is more what's called efficient. It's just harder to work with.
Yeah, harder to implement. Right.
I would never do that because it's too easy to screw myself up.
Right.
So.
Okay.
In other words, the lesson here would be don't make implicit assumptions. Make sure that everything is explicit. You can always refactor this and do more with it later on, but I'd rather you have something that's reasonably efficient and reasonably clear to code. I would argue that this is reasonably easier and this is like harder. So, but the key linchpin of all this was that, hey, I didn't test my design before going into it. I didn't make sure that everything was book solid. In fact, even when I was like trying to debug your code for like 10 minutes to try and really figure it out, I literally gave you a solid example of DIGHJ, right?
Right.
And you should have been able to do that. And so instead what you did was you just kept going through the entire example. But literally, I already gave you DIGHJ as the test case that fails it. So why didn't you just go ahead with that?
Yeah.
So I don't
Yeah, I
know where the
guess-
hell you were going with that.
Okay, so I guess another idea here is start off with like a simple example, right, and then expand it to like the example you gave me.
Exactly. I think I mentioned this.
Okay.
So like when you're dealing with trees, it's this is like the very easy one because trees. There's only a finite number of trees, right? So that you have
Right.
x, let's say of node the node. No. You have x of one child. Let me just make this easier. Plus one child, x plus two children. And each of those have variances, right? And then with parent. So you basically have 6 test cases that you're testing for. And so really, if you had just done that, you would have actually solved your problem.
Yeah, okay.
And so this is why trees, I think, are the easiest problems, because you have like 6 discrete test cases that you can go for that will instantly solve it. And
Cool.
and what you did was just kind of stick with the example that I had given. But yeah, I would argue if you can solve these 6 discrete test cases for your code, you would have been just fine. So this is where like knowing what your test cases are ahead of time is going to be good. So that's probably the lesson from today. So
Okay.
I mean, you have the tools. It's just I would say get a little bit better at avoiding mistakes, not trying to fix them. I think that's
Okay.
what I would say.
Cool.
All right. Any other questions so far?
Nope. I guess for exercise tomorrow, I'll figure out how to do it with the paren rather than this queue. So
Yeah. I think that again, you have the tools. You just haven't been able to put it together. So I think thinking about like why you may or may not why you passed the phone screens, I would probably guess that you've probably seen a lot of the problems that they gave before.
Okay.
Is that about right?
The problem they gave me, I did see it a while ago. I did get unstuck by doing the stack tracing and stepping through the code though, so
Okay.
I was happy about that.
Okay, so you basically have the tools to save yourself, but I want to put you in a position where you
Correct.
don't have to do that. I want you to put in a position
Yep.
where you can just fluidly slide through it. And that's where being able to come up with good logic and understanding what is every single time you make a choice, every single time you make a design choice, there's always a trade-off, right? And there's a reason why I'm going on this tangent. Because every single time you say you're going to do some kind of structure, right? Like the what's called the A, B, and then with pound signs, there's implicit assumptions, explicit assumptions that you're making, and each of those come with a cost. In this case, because it's implicit, you have to remember something going into the code. In which case, like I've acknowledged that, right? And there's some trade-off in the design. So, like I said, with the parenthesis, it's a lot easier to manage because the assumptions, every single action is going to be represented. So all you need to do is iterate through the queue and just follow what action each of this is going to tell you, right? And the reason why I'm going through this is because the system design is exactly the same way. Every single decision that you make is going to make or break something later on down the road, and you need to make sure that those trade-offs are going to be worth it. That's why I say there's no difference between the system design questions and the data structure and algorithm questions. It's exactly the same principle underneath. And so you incurred a cost without even realizing it. Does that make sense?
Yep.
Okay. All right, hold on. I need to use the bathroom, and then when I come back, we'll do the system design.
Okay, cool.
Cool. Let me go ahead and bust out a system design question, and we'll get started. Let me link you the Excalidraw. Wait, where's my sign-in? The hell? Alright, I'm gonna link you the room. Where's the Zoom chat? Okay, cool. Let me know when you can see it.
Okay.
Alright, you in?
Yep, I'm in.
Okay, let me load up some assets for you. Got to do this every time, which is kind of annoying, but... Wait, where did the... Oh. Okay, system design components, there we are. There should be some system design components available to you in the libraries. Let me know if you need me to populate it for you. So let's say that relational database, pipeline, load balancer, CDN, you know, and then, yeah, let's empty boxes, server. Yeah, let me know if you need other stuff, but let me go ahead and pull out the question.
So all those assets, you have to insert them yourself?
I mean, yeah, but because sometimes people in the room can't actually add the assets themselves. There'll be a little book called up at the top called library.
Okay.
And that'll be, that's what you should use.
Okay. Cool. Okay, yeah, I see them.
Yeah. Okay. Cool. Let me go ahead and bust open a problem. Give me a second. Okay. Now we can do this one. Let me get the timer out. Okay. And then here we are. So I want you to design a almost real-time light counter. So it's kind of similar to what you got going at like Facebook. Does that make sense?
Okay, this is for like posts, videos, etc.
Yeah, in general. So you know when you have like a Facebook post, you're just gonna have to like shit, right? And it's gonna be it's like the same thing.
Okay. So let's start with like the simplest example. Let me see. Yeah, let's just assume it's for like one person right now, right? And then
Sure.
can iterate over this.
Sure.
For that, I'll use the relational DB. Let's see. Library. Let's see. Okay. Yeah, I don't see. Okay, hold on one second. Shit. So this is. Let's say this is a user, right? This web app. Because I didn't see the user icon here. And then what would be my web server? I need a web server. Application server. Okay, so at a high level, the user is going to come to this web application. They see a post. They're going to like it. It's going to send. Let's see. It's going to send a request, right?
5 zeros.
Okay. It's going to send off a request to the application server. The application server is gonna go to the application server is gonna go to the from the application server. We're gonna pass in metadata, for example, post ID and user ID, right? It's gonna let me see. It's gonna update a post counter table, right? So you're gonna have posts, and then you're gonna have post likes.
Okay.
Let me. The simple schema is to have a post, right? The post is gonna have your ID, your user ID created by, right?
Sure.
And then you're gonna have your like post.
Mm-hmm.
That's gonna have like post. That's gonna have the post ID. It's gonna have the user ID.
Mm-hmm.
And if you want to get fancy, throw in the created time, right?
Mm-hmm.
So this is let me see the relationship. You have the post. You also need a user. Also need the user table, right?
Okay.
That's going to have, for example, a username, etc. Why can't I type there? That's going to have like username. Last login example, right? Okay, so I'm trying to remember what this is called. I know in SQL this has a special name. I can't think of it off the top of my head. Essentially, it's just it has a post ID and it has a user ID. That's what you're. That's gonna maintain the likes.
Okay, you mean like primary key?
Correct. Yeah. Correct.
Okay.
So then, to query those, you would just have something like to query these. You just have, for example, you query the like post table. You run a SQL count on post ID.
Okay.
And that's going to give you how many likes your post is going to have. I'm probably getting too ahead, but if you want to keep track of metrics, you can have like in the last 6 months, etc. But that's probably going too much ahead of this.
Okay. Well, okay. So I get that this is like a very basic one-person thing, but then, we're not necessarily trying to do this just for one person. So I'm curious where you're going to go with this.
Correct. So the next step is to talk about like we want to talk about numbers, right? Or statistics. Let's say we have this is going to be I'm trying to think here because you have your read to write ratio, right? You're liking posts. Do people like posts all the time?
Okay. Yeah. So you're talking about the read write ratio. Sure. Let's suppose that most people. Well, let me ask you. Based on user interactions, what do you think is a reasonable read write ratio? And I'm curious to see where you're going with this.
I guess from my experience, at least with YouTube, I read more than I write. So, is this a safe assumption? 100 to 1, right? Oh no, sorry. Yeah, 100 to 1. Is that a safe assumption to make?
Oh, that's fine.
Okay. So, given this read write ratio, let's say we have 500 million likes per month. Now, when I'm going through these problems, these numbers, is it for me to come up, or is it just something we can talk out?
Sorry, what do you say?
For these type of numbers, do I just come up with these, or is it just like a handshake between me and the
The
interviewer?
question is, metrics aren't important in the sense in and of themselves. They're important for guiding your decisions about the system. So
Okay,
I could
okay,
have said read-write ratio of 50-50 and a much higher traffic volume, and that might change the internal guts of your system. So I'm going to take, let's say, let me talk as the coach, not as the interviewer right now. I get the
mm-hmm.
feeling right now you're doing metrics for the sake of doing metrics, but you're not seeing how those metrics integrate and create the system or guide the system at all. So I would
Correct.
encourage you to think about, okay, what do these metrics mean in terms of the components I'm going to use? Does that make sense?
Mm-hmm. Yep, yep.
Okay.
Okay, that makes sense. Okay. So we have a 500 million likes per month. So now I want to come up with like metrics to decide if, for example, 500 millions per like, what does that equate to per second, right? Because you want to see like how many queries per second is your system gonna be hit with? Is this the right approach here,
Well,
or do I?
well, you kind of already have part of it, right? With your read-write assumption, you said your 100 reads to one like, right? And then if you just extrapolate that out to 500 million likes per month, although I would argue that the number is much, much more, but yeah, let's. You can already calculate how many queries you're going to hit at minimum just for the likes. That's not counting like all the queries you need for posts and everything else. So ultimately, the number of queries is going to be up to you. You already have a baseline assumption, but how many more on top of that is going to be based on what you design your system to be, right?
Okay.
Let's say, for example, you decide that you need to query, I don't know, a post before you query the number of likes or something along those lines. Or maybe the number of likes, like based on your schema, is okay. So you have the post here and then like post with user ID. Okay, so maybe you don't need to query. Well, actually, no. That you would need to query the post before the likes, maybe or maybe not in your system. So you see, like, how these interactions need to play out. What is guiding
Mm-hmm.
your product, and how does that affect the queries you're going to do? And then from there, you can
Sure.
calculate it.
Okay. Another thing I didn't ask you by real time. Um, do you want it to be like real time? Like I post something, you're gonna see it right away, or is eventual consistency okay for this problem?
Eventual consistency is okay, but we want to make sure that the consistency isn't like the inconsistency isn't too long.
Okay, okay, okay. So based on the cap theorem, if we choose, we can give up consistency for eventual consistency by having availability and partition tolerance. Um, what that means is I can use, for example, I can use a distributed. I will use like a distributed DB, right? Because there's no way like you're gonna basically you're gonna choke your database if you only have one. So I want to have something that's like a cluster, or it's easily distributable, or it can easily scale up or down based on the number of requests. Um,
Sure. I mean that's pretty self-contained. I think a lot of these systems are going to be able to do that. So my question to you now is, all right, now that you know that, how are you going to achieve that?
um, okay, to achieve that, I would have to change from. No, one second. So the first thing to do is to load balance your application, right? You don't want a single. How do I copy this? I would put a load balancer between the web app and the application server. Or wait, does that make sense? No. Because you don't want to have you don't want to send all these millions likes per month through one single machine, right? There's got to be a way to distribute the load. So what I would do is I would put a load balancer between the user and the application. So in case one server goes down, the user can be rerouted to another node, and they can still hit the website.
Sure.
Also, I need to copy this one. I would say I would put another load balancer between the applications and the actual database. So my thinking here is, sure, we can go with relational. You can have like a master slave, right? So this is another trade-off here. Do you want to go with relational or NoSQL? And what I'm thinking here is, for a relational database, you can have your master and use slave, right? Write to the master and do the reads off the slave, and then have replicas of those in case they go down as well.
Okay.
As your data grows and grows, sure, you can do the sharding, right? But you really want to...
So wait a minute. So you're attaching a load balancer to the relational database. Does that mean that you have multiple relational databases and then multiple master-slave configurations?
Correct, yeah. So, however, that's just going to complicate your system, because you have a load balancer and you have to basically synchronize all your masters and slaves, right? If you have, say, 100 nodes, that's going to be costly, right? And it's going to be heavy on your system. So why not choose something out of the box that already scales, like a NoSQL database?
Okay, NoSQL encompasses a very broad, amount of databases. What kind of characteristics would you be looking at? Because, there's MongoDB, there's Cassandra, all those fall into NoSQL. So, which one are you going to pick? And why?
Okay. I know Mongo has it's a document storage database, so there's no schema. You can have, you can embed, for example, the post ID and the like ID.
Okay. So fundamentally, why would a key value store help you here? And why? Why would you pick a key value store for the likes or whatever you want to use?
I would pick something like Redis because it has it's a cluster. It prevents the things we were talking about, so we can easily scale up and down. To quickly, so
Redis is an in-memory cache database, right? With a write-through capability.
Correct.
Why would you use that, and how does that scale? Why would you use that over anything else?
Right. So I know Redis, you can write your results to the database. Let's say systems today now have, let's say, 200-300 gigabytes of RAM capability, right?
Okay.
That's not going to work because as your system grows, you're going to need more and more clusters of that, right?
Okay.
So I'm seeing the negatives if we go through the Redis route there.
Okay, but are you saying you're going to use Redis or not use Redis? What's the benefit and drawback here?
The benefit is that it scales rapidly. The drawback.
Why does it scale rapidly in this configuration? Why does it scale rapidly in your problem?
It scales rapidly because you're going to have a load balancer in front of it, and you can add nodes. You can add nodes as your traffic increases easily, or you can take down nodes, right? So you can basically grow your scale your database and add many nodes to support all the likes that you want to account for.
Okay, but which likes? That's the thing. How are you deciding which likes to hold in memory and which not to?
Correct. Yeah. So yeah. So for that
But keep in mind, also all your data needs to fit in memory, right? So my question now is, how with
Yeah.
let's say 500 million likes per month, do you think we can store every single like in the memory that we've ever accumulated? Think of like Facebook, like 10, 12, 15 years old, right? You might have to. Are you going to store all likes accumulated in those 15 years in the memory?
No, you wouldn't want to do that. It'd get expensive and just a lot of overhead and overload.
Yeah, so that's easily like a couple hundred billion, and then you assume that with each ID, let's assume that there's like 32 bytes in each. What that's a couple billion bytes. That's not even queryable, but yeah, basically you're talking about a shit ton, right there. You know, like even over a trillion, like what that would be a couple terabytes of memory right there. That doesn't sound right.
Yeah, that's no, not feasible.
Yeah.
So there's other alternatives for the NoSQL approach.
Okay.
I know Cassandra supports column. It's a column-based storage. So for the column family, I can do like a post ID. I can do the user ID, and I can also do like the number of likes, right?
Okay, but with Cassandra, you are sacrificing with Cassandra queries, you are gonna miss some of the queries, right? So let's say I do a lookup for some likes, right? It's only going to return me back, I think, 99% or something. There might be some likes that are lost. Do we care?
Right.
Are you willing to accept that?
So by lost, do you mean it's eventual consistently, or they'll be lost forever, for example?
No. So like for queries, right? With Cassandra, do you know how the queries work?
I know the queries happen when you specify like the column family, right, that you want to query on.
Well, that's not what I really mean. What I really mean is when you are querying it, you're gonna get like 99% accuracy. Do you want 99% accuracy? Are you okay with that?
That I mean, you did want a real time counter, so based on the requirements, I would say no.
It's okay. So my question now is, all right. So you know, let me just speak as a coach again. Be very fucking careful when you talk about specific technologies, because I am going to grill the shit out of you.
Okay.
If you bring in a specific technology, I'm going to ask you what are the benefits and trade-offs over every single other one. So if you know it, you better know it like the back of your fucking hand.
Right.
So okay. So my question now is, all right. Well, how do you want to handle this?
I mean, the cache works for hot users, right? It's not you're not gonna load all the posts in there, right? If we follow like the 80-20 rule, they're like 20% of the most popular ones.
Okay.
So I would say now that we talked about doing the Redis, I wouldn't use it fully to store these counts, right?
Okay.
I would want to have some sort of cache, so the database is not heavily loaded, right? Okay, you see a post, if it's in the cache, great, fetch it. If it's not, get it from the database. It also maintains some sort of LRU principle for the cache eviction, because you don't want to keep growing it. You want to keep it at some size, right?
So you're basically using Redis as a cache, fine, but how does this help you solve your? So yeah, sure, you want to cache it, but what's your caching policy, and how are you going to configure Redis to be able to do that?
I would need some sort of service that queries the database and adds the data to Redis. I'm still not clear on the database yet on what to choose. I mean, Oh man. So if we do the okay, you're gonna have 5 million likes per month. This is another idea I'm thinking about is if you throw all your here in this, I don't know, here in the second load balancer, right?
Okay.
What if you throw your request with the like and the post ID, right, and the user? What if you throw that in some sort of queue, and then that queue is in process, and then it's eventually updated to some sort of database, right?
Okay.
Because the other thing here is like, let's say we have a really popular post. You're gonna slam your database, thinking with this relational that I have right now.
Sure.
So
you have one database, but then you have 3 different tables, essentially. Or are you saying
correct.
that each of these posts and users are going to be 3 different databases?
Three different tables.
Okay.
So the like post, that's where we would save the data. So I'm thinking like, because you don't want to send thousands or millions of requests, like say popular celebrity post something, right? There's gonna be a bunch of lines.
Sure.
Right?
Yeah.
So don't hammer your database, because that's just too many writes at the same time. And since it's transactional, you'll probably get a lock of some sort.
Yeah, I mean, a popular user, when they upload something, they're gonna fuck your database. Of course, that's obvious. So now, how are you gonna deal with that?
Yeah, I would have. Okay. First of all, I would have some sort of cache, right, for the popular users, right? However, that still doesn't solve the database choice. Okay. So I'm thinking, if I go with MySQL, if we do the if I go with MySQL and I use the queue approach that I talked about earlier, you can update these records in batches.
Okay.
You don't have to update them at the same time. Okay. If I do that, I can have some sort of service that updates the Redis cache, right? And it's also going to update the most popular post to grab that data and give it back to the user. Yeah. So I'm thinking, if I choose Redis for this, of course it's not all going to fit in memory. That's not a good choice there, because for that I was thinking doing like the post ID and the number of likes, right? Because they have nice libraries for updating counters, but with the size of data, that's not the right approach here.
Okay.
So, I'm thinking of a database that's really good with metrics. If I choose Mongo or HBase, it has the document. It has the document storage.
Why are you storing documents now?
That just has like the like post, right? It could embed the post information in there.
Why do you need to store like post as a document? Doesn't that affect your ability to query it? You're going to take a hit on queries, aren't you?
Yeah, it increases your size, right?
And it's also increased the time.
Right.
Because you're not looking for you're not giving solid data anymore. You're looking for essentially in like file pointers, and then within those file pointers, you are going to be looking for the data you're looking for.
Mm-hmm.
So you have the problem of unstructured queries as well, if I recall correctly. But yeah, like basically, yeah, I know that you will probably get shot on this, so I don't think it's a good idea.
Yeah.
But unless
Okay, so what I want to do is I want to do the queuing approach that I talked about earlier.
Okay.
Yeah, right here. No, oh no. It's gonna go. I need another arrow. Message queue. There's also something here in the middle. Let's see. Message queue. This is gonna be some sort of batch service. Let's see.
Okay. This message queue is your rights?
No. The message queue that's like the message queue. Let me write this down. This is gonna have like the post ID and the user ID, right, and the created time. So what the batch service is gonna do is it's gonna consume the queue. Oh, 1 second. It's gonna consume the queue, and then it's gonna update the records in the database. So.
Okay. So you're gonna batch create the posts. So does it mean that there's gonna be a delay?
Yeah, there is. So that's basically against what we want, right? The real time counter.
I mean, we're talking about likes and you're talking about posts, so I'm kind of curious, like.
Oh, sorry. Yeah. This is to create a like, right?
Okay, so you're going to be batching the likes, all right. But okay, you're gonna send that to the like post, sure. But how are you solving the problem? Because let's say I throw, my 2 billion users at the system and they're all interacting. How does that solve, like, no, yeah, how is this solving it? Because even let's say in the worst case scenario, someone's like liking, unliking. How does this help me? And what's the delay for batch services? Not to mention, you are updating a like post database, which is a relational database. So aren't you going to be locking a particular transaction or?
Right.
I'm really confused right now where you're going with this.
Yeah, I think the problem here is I haven't got that far in my review with this. Is okay. As far as to choose the proper database that can support counts or numbers like this.
Okay. All right. You know what? I'm going to stop it here because they're at 30 minutes, but there's plenty for me to talk about.
Okay.
All right. I'm going to take you out of the hot seat for a second. All right. So what do you think you did right? What do you think you did wrong?
Starting out simple. I started off simple. That was the good thing. The bad thing was talking about technologies with the database. Yeah. I think that shot me in the foot. Also, not having a proper tool or database for this problem.
I'm gonna say you're focusing on the wrong thing. You're focused on the forest for the trees. I'm gonna tell you, there's so many fucking databases out there that it's like literally I can't keep track of all of them. There's like so many different ones, right? That'll solve all of your different problems. The problem that you have is that you didn't focus on solving the problem. You focused on just kind of picking a database just for the sake of picking a database, and you didn't really try solving the actual problem at heart here, which is reflected by your inability to probably decide what your specs are, what your functional and non-functional requirements are.
Okay.
So that's basically the gist of it. Let me paste my notes here. But in general, I think the best way for me to just kind of like go through this, instead of me like nailing you on every single step, I'm gonna actually show you how I would have solved the problem. And then maybe it'll make a little bit more sense. But basically, the bottom line you have here is that you had no direction. You didn't know how the metrics and these functional requirements fed into your system and how it formed your system, right? Like I said before, if I have like a 50-50 read-write ratio versus a 100-to-1 read-write ratio, that's going to change the way you're going to set up your database and the way you're going to set up your entire fucking backend, right?
Mm-hmm.
So let me do the problem, and then hopefully this makes sense where I would go. So let's say I'm doing Facebook. I would need to figure out my functional and non-functional requirements. Let's start with a basic interaction, right? With Facebook, I'm going to be essentially I'm going to be get a post with likes in it, and then I'm also going to want to like the post, which is tantamount to updating the post with likes in real time, which is then going to lead me to, okay, what exactly is real time? How critical is this on a scale of 1 to 10 from the system? Do we care? How accurate are we? Do we care how accurate? You know, is like, you know, having like 1 million versus 1.01 million likes going to kill us? You know, if Kanye fucking posts, and do we care? If we if we display, hey, this post has 1 million likes versus 1,000,001 likes, I'm gonna say probably not. That eventually we can kind of guess, we can kind of be a bit inaccurate with likes, especially at high numbers. You know, if it's like 12, 13 people liking it, okay, maybe we care, you know. But in general, once we get to the higher volume of likes, probably not. So I'm going to say, all right, so given that, is that we can tolerate some kind of eventual consistency. So let's go do the functional requirements and then non-functional requirements, right? Functional requirements is just like, okay, what exactly do we need the user to do, right? Okay. So the user is going to be able to, you know, be able to like the post, unlike, and then also an idea, right? If I like a post, do I want to be subscribed to it? Okay. So let's say unsub from post likes. Because let's say I like a post, or, you know, I'm viewing a post, maybe I want to see all the likes that get updated on it, right? So let's say, again, if I like my friend's post, and I'm looking at the post in real time, do I want to refresh the page to see all the new posts that come in? You know, that's something to think about. And you know, maybe it's like critical or non-critical to the system, but at least I have it on paper. At least I have this fucking thing I'm doing and I'm considering on paper. So that's kind of like what you really want to be doing, like making sure that all the things that we could possibly be doing is on paper. That's what we call scoping.
Right.
So it's like, hey, these are the things we're going to be considering. Here are the things we're not going to be considering. And here is where they are on the priority list. Do we want to punt them? Do we not want to punt them? Et cetera, et cetera. So, okay, next thing. So let's say the non-functional requirements, right? This is where your cap theorem and is going to come in. So cap theorem, like we established. Consistency, availability, and then partition. So, well, with distributed system, you're guaranteed P. So, which means we choose whether to give up C or A. So, let's give up C per our previous discussion of, oh yeah, 1 million likes is not gonna fucking kill us if we're off by a little bit. So you want to have also, like, and then also, like, the level of availability we want. So let's go up C, so which means we pick AP, right? So, level of availability. So, I would say we want high availability. Because moderate or low is like, if a user has like low number of likes and they like it, and then like a server goes down, are we okay? Are we tolerating? Do we want to tolerate that? Like a minute delay or some whatever? Probably not. So probably don't want to tolerate, right, lots of downtime with likes. You know, because the likes represents engagement and shit for our system. And then also probably like, you know, scalable distributed. So you notice here, all I'm doing right now is just scoping out the fucking system. I'm not really doing much else beyond that. All I'm saying is like, hey, here's what we want to consider, here's what we don't want to consider with the system, et cetera, et cetera.
Okay.
That's what you really want to do. Like, hey, this is here's how the system should interact with the user, here's what the user expects, and here's how it affects the system requirements. Right? Okay, so next thing, let's actually try and hammer this out based on what we just kind of discussed back and forth. So let me go ahead and get like a user software architecture, browse libraries, architecture diagram components. Let me grab like a user out of this. Right, so I'm going to have a user. And then I'm going to have my application, right? So let's just handle the core requirements for now, which is like being able to like this shit. So user's going to attack the server. Server's going to attack our backend, right? So the backend's going to be like, okay, well, let's define how we're going to do our schema, right? I think what you did here for the post and like is going to be fine. The only thing is that what I would do is I would actually put the post in one database. Like the super naive solution. Let's rewind a little bit, actually. The super naive solution is to jam them all into one database with a, in like one database but two different tables, and then do like some weird joins and shit. But the thing is that if I take it to its logical conclusion, I'm going to say, hey, wait a minute. I'm going to have a shit ton of posts. I'm going to have a shit ton of likes. Making that all live in a fucking database is going to be really, really bad. And so I know I'm going to need to have like a new database, right? So I'm going to separate that into posts and likes. Let's call this a NoSQL database. Per like our discussion, right? And so it's like, okay, I'm going to say let's have an unstructured or NoSQL. I know that's going to be what I'm leaning towards because I don't care about having a structured query. All I really care about at the end of the day when it comes is the number of likes.
Right.
So now the question is, okay, am I willing to accept some penalty in accuracy? Well, yes, because I just established that once we get to like 1 million likes, I don't give a fuck, right? So I'm going to say unstructured NoSQL for posts, for likes, right? Because I don't care, because let's say the likes database is going to have a user ID per your schema, post ID, and then let's say the timestamp.
Okay.
I think this is pretty reasonable, right? So now the question becomes, okay, when I make this request, I need to be able to get the post, and I need to get the number of likes, right? So the question now becomes, okay, so instead I'm going to be essentially doing two splits, right? One to the relational database, one to this. So remember where we started from? We started from jamming everything in one relational database and then just taking it to its logical conclusion with the requirements where we have like the 500 billion likes or whatever. Jamming the relational database is just to get these. It kind of sucks ass, but just getting the likes is different, right? So now the question is, okay, well, am I okay just when I get a post, and then am I okay locking like the entire object store or whatever just to get one post? Probably not. I'm not. I wouldn't say so. So before we handle like the asymmetry problem, let's just consider. Okay, well, all I really need is just the like number, right? I don't really care about the likes themselves, so I don't need to query it. I just need to get the like number themselves. So maybe what I can do is instead have some level of coordination between the relational database and object store, where every so often I have some how do I know? What do I say? Like maybe some service here.
Some job or service.
So like some aggregate service that just reports back the. Oh wait, I just dropped my. Hold up. Let me get back my thing again. Shit. I accidentally minimized everything because I knocked over my water. All right.
Oh shit.
That's fine. All right. So yeah, I have this. Maybe I want some aggregate service. Maybe not. Let me get back my. That service or not. Maybe I want to put in a relational database. And then I realized, wait a minute, I'm just attacking this from two ends. I'm going to be writing over and over again. So maybe let's not fucking do this. But I do know I need to aggregate the likes in some way, right? So instead, let me go ahead and just query for like some, I don't know, let's call it the like service.
Okay.
And I know that for the like service is going to have to return to me back the number of likes. So which means that it's going to have to do, let's call the aggregation service. The aggregate service will then call the object store and be able to get this for me. So the aggregate service will be like, okay, well, now I need to be able to cache the likes that I've aggregated. So maybe, okay, that's where maybe we want to start considering using a memory store. Because then it's like, okay, well, I need the let's do this.
Yeah.
So let me get like some cache here, right? So the cache might actually be useful here because, hey, I only need to store like the latest number of likes. Like, okay, wait, why? And I'll say because the posts that have, that are most recently updated are the ones that are going to be mostly frequently interacted with. So we'll hit this caching mechanism, right?
Mm-hmm.
So in other words, this cache mechanism actually reflects what happens in the object store. So it's like if I don't get it from the cache, then I'll go ahead and get it from the object store. So I mean, I'll do that, and then I'll update the cache. We can have an LRU, a eviction policy, based on the fact that people are more interested in the likes that have been most recently updated. Okay, let's take that to its logical conclusion, and we arrive at, oh yeah, well, we have also an asymmetric interaction with it, right? Because the Kanye example, like if Kanye posts, everyone's gonna be fucking liking that post and not liking their friends' posts. So in other words, that's where we can start having like a distributed cache. So let's, instead of making this call, let's call it a distributed cache. distributed cache, right? So everyone's gonna be reading off of like, let's say Kanye's post, but then if we decide, oh yeah, let's like, if we had it all in the object store without this cache, we'd be like fucking jamming the object stores just to hit all the just the likes for one person, which kind of sucks ass, right? So there's no way we would do that. Plus, we are okay trading off the 1 million accuracy versus 1 million 01 accuracy, and so this cache can eventually be updated eventually from the object store, which is fine. Again, the 1 million versus 1 million and 1 likes, we don't care. So that kind of takes care of a little bit of that. So which means that when a user gets a post and the like service, they're gonna be able to get this pretty quickly just because we get the likes from the cache, and we only have to query for one post. So the way, if I recall the way like MySQL works, we only lock up one row for that, which is a very easy, inconsistent, because we're keying by this primary ID, right? So we hit it and we get it, we're out of there. Get the next guy to going, right? And we can multi-thread that all we want. And if we really want to, we can kind of just we can cache this too. But for now, I'm still handling the core issue of, hey, user gets post, user gets like, and then likes, I'm just diving into it based on the problem that I have described, right?
Right.
So all I'm doing is digging through this like service shit.
Right. So for this makes sense for reading, right? Reading the likes.
Right.
So for posting a like, it's gonna go through the same path there that you have there.
Yeah, we can make it do
the like
that.
Service.
We can kind of make that do that. We can make it do that too. Instead of calling it aggregation service, because aggregate means that, hey, yeah, I'm gonna query the object store and then update the cache, right? We can have a, say, I don't know, let's say we have an update service.
Okay, cool.
We have an update service where the job is to update the cache, update the cache or the object store. I would say probably the cache, because we have like I said, we don't really care about the accuracy numbers once they get very, very high. If we did care, I would probably argue put it in the object store and then eventually get it from the aggregate service. But since we don't care, then we can kind of go here. Plus, like if for low activity posts, like your friend's post who has only like 16 friends, chances are it's not getting updated very often. So I think we can accept that penalty fine. So let's say we hit the cache, and then now we arrive at the problem like, okay, we have this hot user who's getting like constantly updated, constantly getting read, right? We can do like, now we have to decide a better policy for it. Now this is where distributed cache comes in, and we can do like a fan out policy. So what policy do we want? So fan out policy for popular posts.
Just for like celebrities, right?
Yeah, exactly. So like if we want to dive deeper into this, for celebrities, could it be hot celebrities with like, let's say 1 million? We could spin up their own shard for it, because there's not too many of those, right? And then everyone else we just put on their own other clusters. But also we can also say, hey, yeah, let's, instead of doing that, let's also just put let's do like a round robin thing where we put one hot user and then 1 billion not billion, let's say 1 million not hot users on the same shard or something like that. So we sharded by number of followers, and then once a user crosses a certain threshold, we rebalance it. Something like that. But you notice here, like how I'm trying to solve the problem. I still haven't named a single database yet. All I've done is just say, hey, here's roughly what it should work on, what it should look like underneath the hood.
Okay.
That's all I've done. All I've done is like kind of describe what the properties we want, and then from there on, we can kind of decide what kind of database we want. But all I've done here is just say the rough description of what we want.
Okay, cool.
And then from here on, we can just do that pipe thing that you did with like batch updates if we really want to do that. And then we can have a subscription going into the post update service and whatnot. And then for the subscription, unsubscription, we can use WebSockets, long polling, or whatever the hell. And then after that, let's say we want to do metrics. I'm kind of breezing through this just for the sake of time. But then now it's like, okay, now that we have this, how do we want to monitor all these things? We want to be able to check, like, I would say to make sure that this all works and that we're not getting fucking, getting fooled into thinking a delayed update and consistency versus a failure. We can just have a dummy post or dummy events and just run it through the system, and just to make sure that everything's okay. So like, let's say I'm gonna create a dummy post and have dummy like events on that dummy posts. That would be how I would make sure to check the health of the system, make sure everything's okay. I wouldn't try to like query the object storage. I mean, I could, but I think what's more important is to be able to make sure that these services are running. So we just pepper in some dummy data just to make sure all this shit works. And then as far as like business metric goes, We want to see how many users like are subscribing, how many users. We won't want to say how many users are liking it, but maybe likes per hour.
Okay.
But I don't know. There's a high volume of likes, so keeping track of that and doing a population of that might be a little bit difficult. So maybe we want to batch. We want to update metrics on updates. Yeah. I wouldn't say reads because we can't really get business metrics off of number of likes. I don't know. This is where we have to start putting our business hat on. It's like, do we as a business benefit from keeping track of the number of times a single user likes a post or a single user likes something? Probably not. But we do get a... Because we can always just query the object storage here for that if we really wanted to. We don't need to do it in real time. So, I mean, we definitely want to query the object store eventually for those likes. But we also want the user opt in and out just to see how many users use that service. And that way we can kill it if we need to. But the like is pretty core, so. But you see like how I'm going back and forth with this, just making trade-offs, like why or why not these things might be useful. And I'm kind of keeping it within the a frame and scope that I've defined up here. Right. And I've done that all in 15 minutes. I would say this is pretty much a reasonable answer. I don't know how much further I could go with this. But the point here is that I have a scope. I am using this as my North Compass. I am going to just fucking jump around in it within the scope that I've defined. And I would say that's a pretty reasonable thing to do. Does that make sense?
Yeah, that makes sense.
Okay. So the last 15, do you have any other questions?
No, just a comment. I think what kind of threw me off was like selecting the right TV for like the metrics.
Uh-huh.
But I totally missed the point of having some sort of accurate service, right?
Uh-huh.
So yeah.
I'm gonna tell you right now, when you look at shit like this, and you look at like services, when you look at like a system, it's much easier to change the system and write up some new code or product than it is to change the entire database. If you disagree, just try migrating from one database to another. Ask anyone who's done that and see how much they would rather hang themselves than ever do that ever again.
Yep.
It's like you accidentally drop tables in production. Yep. So I'm gonna tell you, as long as you set up this correctly, and then you define the scope, then you can choose the right database. The database and technologies should serve the problem you're solving, not the other way around.
Mm-hmm.
So, in other words, what I want you to do, actually, and let me write this down on your prep doc. So, we're going to talk about your homework. So, let me pull it up again. So, your homework. So, go to Grok. So, I think I've outlined this in the guide, but basically, go to Grokking the system design, and then start doing problems.
Where are you in the Google Doc right now?
I'm in your prep doc. Not their problem sheet.
Okay, let me open that up. Okay, I see it.
All right, so start doing the problems. Really, you want to structure your approach. And I'm going to give you a basic one, right? Scope, and then once you've scoped out the problem, start with a basic design, and then drive each portion of the design to a logical conclusion within the scope, and don't name specific tech. You want to grow the problem based on whatever we've defined in the scope, right? And I feel free to rewatch the stream and see how I went through the logic of this. Mm-hmm. But basically, I never once named like, oh, we should use Amazon EC2 or we should use whatever this fucking technology is. All I described is what exactly the characteristics of the database and the system are going to have.
Wait.
So, in other words, focus on the characteristics and derive the logic for it. Tell a story.
Okay. And that's where you decide the business hat that you mentioned, right?
Yeah, every decision should help you solve the problem and go get one step closer, right?
Okay.
It's the exact same thing as the data structures and algorithms. If you decide to use a hash map, why the heck are you using a hash map? If you're using, like array or whatever, this algorithm, there has to be some justification. In our case, it's always, in the data structures and algorithms one, it's always like, what is inefficient about it? How to get better? In this case, it's the exact same thing, right? It's what is inefficient about our system under, XYZ, whatever we got going, right? Versus our million likes that are funneling through the fucking system every single second. Why do we need to make this decision? It's because it's not going to handle our business use case and it's inefficient at that or something like that. You know what I mean? Every single decision that you make for design should have a logical backing and reasoning for it.
Okay.
Okay.
So inside the scope, that's where you talk about like the functional and the non-functional requirements, right? Do you also talk about like the APIs, or that just comes somewhere along your design?
Eventually, I'll get to the APIs, right? It's like, okay, well, now that I've designed the backend, I can say how the user is going to interact with it, right? Because now I get specified, hey, we want to open up a WebSocket or not. We want to open this up to developer. But I would argue that this is actually relatively simple, because all it is just like, get a post, and then in the return field it'll just have it'll have ID, user ID, and then maybe not even user ID. It'll just have the user metadata that it needs, and then it'll have like a link to the post. Well, not really post, the photo or the video, format ID, etc., etc. And then the likes, and then it would just display the number of likes underneath.
Okay.
So I would say that the API for likesing, for getting a post, you can't get a number of likes for a post. That's not gonna be an API. All you're gonna do is get you're gonna have an API for getting posts, and then you'll have a put request, a put API for liking a post. That'll take in a post ID, user ID. Well, actually, you don't even need the user ID necessarily, because you already have like a user token for that. And then you just have a like post, and then that will just be able to do that for us. And then you might, in the web server, you might have some rate limiting shit going on as well. But the API is relatively simple. I don't think it's terribly complicated in this.
Yeah.
So I would say, like, eventually you will get to it, but it's not complicated. There's some of them that are complicated, like designing like a Facebook feed that you might actually want the API for, because you might want to be able to specify, hey, we want to get a post, and then be able to jump in and get the data for the post when we'll click into it, and which would include like first and number of comments and number of likes and all that shit. So yeah, that's basically my issue. You notice here, like, there's always a thread that you're pulling, that you can always go deeper. What happens at the logical conclusion? Eventually, like, what happens if we overwhelm the distributed cache? What happens if our popular posts doesn't really work out? Do we need to make sure that these global? Do we want to make it so that way if we find out? I don't know, like if Kanye again. I always keep bringing up the fucking Kanye. Fuck this. Imagine if, like, instead we had a quote unquote localized version, Facebook, like Yik Yak or something, and we find out that the people who are most actively engaging with these celebrities are local celebrities. Like, people in California mostly interact with celebrities from California, and people from Britain are mostly interacting with people from Britain, like Dua Lipa. So then we could start, saying, oh yeah, well, we will mostly have the replication of the cache start in the area in which the person is from, and then eventually make it consistent around the world. We're willing to give that up because, people in, let's say, fucking Russia don't give a shit, or I wouldn't say don't give a shit, but they don't really query for Dua Lipa or whatever very often, and vice versa. Yep. So, it's like basically taking into account how the system is being used and knowing what your options are under those conditions. So that's why I say, like, a lot of the times system design comes down to what you think is important and what you don't, and that's based on experience.
Okay, that makes sense.
So I know I kind of talked a lot, but hopefully this gives you a sense of how to think about these things.
Yeah, no, for sure, man. Thanks. I had another question. Like, let's say you do a problem, right? Like, you don't want to rely on memorization. So, How long do you wait to do it again? Any advice there?
Well, the thing is that if you know how to describe it with data structures and algorithms and system design, you're bulletproofing your approach, right? So in other words, if I'm not able to get a problem with the approach that I'm currently doing, the next thing I need to do is ask myself, what are the questions that I need to ask myself in general that would apply to any given problem that would allow me to make more progress through the problem, or at least solve it. So that's your North Star. It's like, hey, if I were to redo this problem with this framework, would I be able to do it? The answer should be yes. And in which case, you can come back to it after a month or two, after you've, tried a bunch of other problems and thrown at the framework, and if the framework isn't able to reasonably solve the problem again, then you fucked up on improving your framework. That's what it means.
Yep. Okay. Yeah. So like the system designer is like, okay, next time I can come up with like some sort of service rather than deep dive and choose technology, right?
Well, the thing is that the questions that you're asking yourself. So let's say, like, if I were to look at your performance and like say that's mine, I would say, okay, well, Edward gave me the answer here, right? And that's why I say it's good to have an answer key. Edward gave me the answer. What is it going to take for me to do? What's the difference between what I did and what Edward did? All right, well, and not the design itself, right? The question that he asked himself. What did he do? Oh, he got the full scope of the problem first. Whereas, what did I do? I just jumped around and tried picking databases. Okay, that's a mistake. Why is this a mistake? Did Edward name a database? No, he never did. So why am I doing it? You know, and it's like, okay, well, I don't need to do it because X, Y, Z, blah, blah, blah. And so now I also need to scope out, like, how the user interacts with the system and what the user expects. Okay, that would cover 90% of what Edward talked about here. Fine. Okay, what's the next thing I need to do? All right, so what I need to do next, based on what Edward did, is just say, oh, he just ran through the simple example of merging the likes and the posts together in one database, and then through the business problem and the functional and non-functional requirements added, and said, hey, what happens if we scale this out? Oh, yeah, it goes to shit. So what did Edward do? Oh, yeah, he split it up because of how it would react, you know? It's basically doing that, right? But then with grokking, the system design, you're not going to get that. You're going to get more of, here's the final answer.
Right, exactly.
But so what you need to do is come up with a line of questioning and system that will be able to get you there. And I'm kind of giving you the framework for that, where it's like, oh, yeah, just start with a basic system and then take it to its logical conclusion. So you should really treat grokking the system design as an answer key. So the next thing for you to do is really just come up with those questions and actions that you need to do yourself in order to get the answers that they do. Or if you don't agree with those answers, why or why not? And make sure you have a good justification.
Okay, cool.
Does that make sense?
Yep, that makes sense.
So what I want you to do for homework, and we're going to meet on Thursday, I want you to record yourself doing the problem. I want you to use Excalidraw, and I want you to record yourself talking through it.
Okay.
And then after that, I want you to be able to do a write-up of the... Let me write that down, actually. So, for replay analysis, do a grokking problem. Record yourself doing it on Excalidraw. Do a write-up of what you did right, wrong, what you can do better, what questions you need to ask yourself, what is the delta between grokking and you. Okay. And there's also like the leak code. I would recommend you do leak code on the weekend because you kind of fucked up here. So.
Yeah, for sure.
Okay. That's it. Any questions?
Cool, man. Yeah. So I think your approach is a little different than what grokking does. I kind of like yours better because you started out with the simple approach and you iterate on it. But in grokking, it seems like they just give you the solution there. Yeah. So, yeah.
So in other words, your job is to keep figure out what questions you need to ask yourself in your approach in order to arrive at the answers that grokking does.
Okay. Is there any specific leak code you want me to do for the replay analysis?
I would do elements of programming interview, actually. I would say pick a tree problem, tree problem or any of the challenge problems. I think would be good enough. We'll talk more about it on Thursday, but I want you to try getting the system design off the ground first.
Okay, sounds good. Okay, awesome.
All right. Any other questions?
Cool. No, we're good.
All right, sounds good. Then I'm going to let you go.
Cool. Awesome. Thanks, man.
All right, see you Thursday.
See ya.
Okay. Any questions from the crowd? He went straight for it without questions. Yeah, we covered that. You want to be able to do a bulletproof approach that is logical and consistent and be able to get a lot of your questions out of the way. He was hopping around. Yes. It's because people hop around because there's no structure to their thinking. And what I just did today was give him a basic structure. Now all that's left is for him to fill in the structure with questions and pieces of logic and reasoning that needs to be done. Edward, what's the minimum number of leak code questions one should do to pass coding assessments? I can't give you a number. Well, I can. If you're doing it right, it should take you no more than 100 questions. If you're doing it wrong, it doesn't matter. You could do 400 questions and still fucking fail. Look at any of my past clients who started off doing 400 questions. They still couldn't pass coding interviews. So my suggestion to you is focus on bulletproofing your approach. Bulletproof your approach and focus on making that better and better and better. If you do that, eventually it'll be plainly obvious you're ready. So I can't give you a number, but I can say that if you're doing it right, you only need no more than 100. I guess I'll put on some Dota while I wait for other questions. I'll turn off the stream in like 5 minutes if people aren't going to are going to ask questions. So.
To see the dawn.
Damn, they have a new Resident Evil game? Oh shit, I haven't played that since high school. Did I play Resident Evil in high school? I don't quite remember. I think I played Devil May Cry 2, and that was hard. On the PS2? Yeah. Alright, let's see what he got. Oh,
Bro, we
man.
should be going on them. Why is Mars AFK?
Did they win? Oh.
Mars doesn't have the killer instinct.
Oh, that sucks.
How's Aegis?
Yeah, alright, they're gonna blow him up. Oh, he's gonna BKB anyway, but he's good now. Yep, there you go. Refresh.
Bro, I don't know, Mars. You're literally just AFK. I don't know how to play with you. You're so fucking bad.
I mean, refresh black hole. There's nothing you can do. There's no way to cancel it. They have nothing that pierces stuns other than the tusk roll. I mean, I guess the tusk could have saved him, but I don't know. It's kind of hard. All right, GG. How many years of experience does C have? I think he has like, I want to say like 5. I gotta remember. I gotta ask him again. I kind of want to say that, but yeah. Let me make a note of that. I should ask, but I would guess that he probably has like. I would guess 5 to 7. Like probably like the rate he asks those questions right now makes me think that he is kind of like a mid-level L4. Yeah, I would say mid-level L4, not upper L4 for sure, but yeah, I think that we might be able to reach for the L5 if we're lucky, but it's gonna take a while. If you're an Android developer, do you still need to learn the system design interview questions? You really don't, but you still have a different version of it, right? You're gonna have a different version of the system design for Android. So, based on my experience, you're going to have the client-side version of it. So, how are you going to architect the app? How are you going to organize? Let's take a sample example, right? From I think one of my interviews. So, design the LinkedIn, Facebook feed for Android, right? You're going to ask yourself, okay, what is the API that you're going to expect from the server? What are you going to do for the or how are you going to organize the data models? How are you going to architect the app? What are the developers going to, how should your app respond when we want to develop new features? How are you going to do the navigation? Probably not. What database, how are you going to store like the data that you get from the feed? Are you going to use like the rooms database, or are you going to use something else? Like how would you architect the software architecture for this? So, like, would you use model view model, or would you use model view controller and all that stuff? So that's basically the way I would describe it. It's not too dissimilar from the actual system design interview, except that you're not dealing with like a sharding policy. You're really dealing with like how to describe it. You're dealing with more Android specific components, but it's not too dissimilar. The logic behind it is going to be exactly the same. You know, you might also say another one. Like, let's say you have like an image loader, right? Design an image loader for the Android app, right? You might implement you might have a circular queue. Well, maybe not image loader. Let's say like a lock screen a program that will change the lock screen on your phone, right? Every time you power it off, like you put the phone to sleep and then you put it back on, like just click the power button, it'll change the photo. And so you would basically do something like, I don't know, you would have a service that background fetches the app. You have some caching mechanism that gets the thumbnail, or and then you would try and create like a core circular queue logic that would just iterate and go through every single photo, right? And then be able to display like the low resolution version until it downloaded the high resolution version. And then you would be able to have like some background fetching service that got the high resolution version or something. And then you would be able to structure off like that based on like, oh, what happens if there's like low latency or a bad network? What are the different configurations and situations the user can find themselves in? It's like that. So the core logic is exactly the same. It's just that the components you're using are very different. So hopefully that makes sense. All right, I guess I'll stop the stream for today. I'm getting kind of hungry. Thank you all for joining me. We will be doing one another session on Thursday. So hopefully you join me for that. 8 p.m. We'll see like what progress he made, and hopefully he made some, and we'll have something to talk about. So thank you all for joining me. I'll see you all next time.